Hello and welcome to another video. In this video we are looking at how to use the Ti-83 or Ti-84 graphing calculator to solve applications of the normal distribution. This is the third video or fourth video in the normal distribution section. So make sure you go back and watch the previous videos if you have any questions about what we're working on. I have three main steps that I always like to identify when we're working with normal distribution questions. First one is to draw a normal curve. For each of these examples in this video, I have a sketch of a normal distribution that we'll add some information to. The second thing we're going to do is identify whether or not the question wants us to find an area or find a score. If the question wants us to find an area, that means that they will be giving us values in an interval, and we'll use the Normalcdf. If we are asked to find a score, that means that they are giving us an area, and we're going to use the inverse norm function. And the third thing is to read the question and make sure that the answer that we find actually answers the question. All right, let's get started. Example 6.8 says the golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. Find the probability that a randomly selected golfer scored less than 65. Well, I know I've got 68 as the mean, 65 as my value here. I want to find less than 65. We want to know what's the probability that a randomly selected golfer scored less than 65. Well, we're just going to go to second vars, which brings up the distribution window in the TI calculator. We're going to choose number 2 because we have been given a score and we want to find the area or probability. So therefore we are going to use the Normalcdf function in the calculator. All right, since we are going to go less than, our lower shaded region technically goes to negative infinity. So we're going to use negative E99 as our lower bound, and we're going to use 65 as our upper bound. To type this in the calculator, it's already entered for me. If you turn your calculator off and then back on, it will generally automatically reset to negative E99. For those of you who are using the older display Ti-84 or are using the Ti-83 calculator, give me a few minutes. Once we get through this, I'll show you how we can type those in as well. If we needed to type in E99, we could type in, negative, use the negative button down in the bottom row, hit second comma, and then type in 99. And that'll give us negative E99. This is the scientific notation for negative 1 times 10 to the 99th power, or negative 1 with 99 zeros, some gigantically large negative number. Our upper value is 65. The mean for this distribution is 68, and the standard deviation is 3. We're just getting those values from the word problem itself. And then we'll go down and press paste. And this is what you, if you're using the older display Ti-84 or if you're using the Ti-83 calculator, this is what you will need to type in as well. Drop that here so I can talk about it. And we'll get that the probability is 0.1587. 0.1587. Whenever we're working with these types of questions, we're going to round the probability to 4 place values, unless you're told otherwise. All right, so if you have the older display, no big deal. You're going to do the same thing that we're doing here. The lower value gets typed in first. Make sure you use the comma. The comma is the button just above the 7. Then the upper value, then the mean, and then the standard deviation. And as long as you type it in that order with commas between them, you'll get the same solution as what we have here. All right, let's move on to the next one. It says 2,000 students took an exam. The scores have an approximate normal distribution with a mean of mu equals 81 points and standard deviation sigma equals 15 points. Calculate the first and third quartile scores for this exam. All right, so a little bit different here in that for part A, we are given the percentiles. If we are given the percentiles, it's basically saying that we are given the area and we're being asked to find the scores. Asked to find the scores. So for part A, we're going to use the inverse norm function because, again, we're given the area and we want to find the scores. So on my picture, we know that the mean is 81. The standard deviation is 15. We want to find the first and third quartile scores. Well, we know that the first quartile from prior lessons, the first quartile is the same thing as the 25th percentile. The 25th percentile, it just means that we're trying to find the test score that has 25% of the others to the left of it. So since we're trying to find the value, the score, we're going to use the inverse norm function. The area to the left, again, in my particular calculator, I'm not able to choose left, right, or center. In some calculators, the newer ones, you're able to choose left, right, center. In mine, I'm not able to. So I like to joke around and say that whenever we're using the inverse norm function, we need to think of Beyonce, because Beyonce is famous for singing a song that talks about everything being to the left. In my calculator, the area has to be to the left. And we know that the mean is 81 and the standard deviation is 15. It's given in the question. So we get that the score here for Q1 will be 70.88 or 70.9. So the first quartile is the test score of 70.9. Now we can do something similar for Q3. Let's choose a green color here. It's not letting me choose green. There we go. So we could choose a green color here. That's not quite 75%. We're looking for the third quartile now. So we're looking for all the values that are to the left of this Q3 value. Again, the third quartile just means that 75% of the scores are to the left, or are less than. So my area is going to be 0.75. So I will type in second vars number 3, change the area to 0.75, mean of 81, standard deviation of 15. And I will get my third quartile is 91.1. Now, if you have one of the newer calculators that has the left, right, center, you could also have chosen to just change it to the right tail and use 25% as well. All right, so there's the two values for the first and third quartiles. Now, part B says the middle 80% of the exam scores are between what two values? So I have a second normal distribution here. I'm just going to shade in approximately the middle 80% of the values. So 80% of the test scores are between some lower value and some upper value. Now, based on this, there are going to be two answers. We want to know what are those two values. Well, we know again that the mean is still 81, standard deviation is still 15. We need to do a little bit more work here. If we know that the middle 80% is given, Well, that means that the two tails will be 20%. 100 minus 80 is 20. And since these two tails are going to be symmetric, we know that each tail is going to be 10%. So in my calculator, I'm going to hit second vars, number 3, 0.10, 8115, enter. Again, if you have the older display calculator, you're just going to type in inverse norm. 0.1 area to the left, 81 is the mean, 15 is the standard deviation. And we'll get that the lower value here is 61.8 or 61.77. And then the last one we need to find is the upper value, which in my calculator, I need to type in the area to the left of this upper value. The area to the left of this upper value will be 80 plus 10, or 0.9 or 90% to the left. So I'm going to do something a little bit different here just to show you another way of working with this. If we hit second enter, we can just go back and change this from 0.1 to 0.9, and we'll get the upper value of 100.2. We have one more example we're going to work on. And this example says, a citrus farmer who grows mandarin oranges finds that the diameters of mandarin oranges harvested on his farm follow a normal distribution. So as soon as we see something like this, we know that we can draw these pictures, and we can start applying either the normal CDF or the inverse norm. With a mean diameter of 5.85 centimeters and a standard deviation of 0.24 centimeters. Part A asks us to find the probability that a randomly selected mandarin orange from this farm has a diameter larger than 6.0 centimeters. All right, well, we know that the mean is 5.85 because it's given to us. We want to know what's the probability that a randomly selected orange has a diameter greater than 6.0. So I'm going to shade to the right. Now let's just talk which type of function are we going to use. We are given the value, or the score, in this case the size of the mandarin, and we want to find the probability. So if we are given the value and we want to find the probability, we're going to use normal CDF. Press second vars. Number 2, normal CDF. Now we need to change this up a little bit. My lower value is 6.0, and my upper value is technically infinity. We can't type in infinity, so we're going to use E99. Again, that's just scientific notation. So I'm going to type in 6 for my lower. I'm going to type in E99 for my upper. I'm going to press second, comma, 99. My mean is 5.85, and my standard deviation is 0.24. Again, if you're using the older display calculator, not that big of a deal. The lower bound is 6, the upper bound is E99, comma, the mean is 5.85, comma, 0.24, and again, the comma button is above the 7. So we'll find that the answer here, the probability that we choose a randomly selected mandarin, and it has a diameter of 6.0 centimeters or more, will be 0.26598 or 2660. Always round to 4 decimal places unless you're told otherwise. All right, in the last two examples, I forgot there was a part C. Part B says the middle 20% of mandarins from this farm have diameters between, and then there are 2 values here. Well, if we're looking for the middle 20%, we're looking for this approximate area. I know that the mean is still 5.85. I know that the standard deviation is still 0.24. Just getting that right from the question again. I'm going to write it because I'm going to scroll down a little bit and we're not going to be able to see the question itself. All right, so we're looking for a lower value and an upper value. If you have a newer calculator than mine, then you can do this with a quick trick. I'm getting ahead of myself though. Let's just talk really quickly which type of function we're going to use. Since we are given the percent, which is the same thing as the area, and we want to find, that's my joke, WTF, want to find the scores, we can use inverse norm. So what I was saying just a few seconds ago is that if you have a newer calculator, you also have an option of choosing where you want to shade. If you have that newer calculator, you can type in the area of 0.2 and then choose center. I don't have that option, so I'm just going to get rid of all of this. We need to do a little bit of work just to figure out what is in the tails of this graph. So if I know that this graph, the shaded region is 0.2, then I know that the tails of this graph will be 80% of the picture, or 0.8. Meaning that each little region here will be 0.4. Right? 80% divided by 2 will be 40% in each region. And we can just double check that. 0.4 plus 0.2 plus 0.4 is 1. All right, so in my calculator, again, I can only use the area to the left, as Queen Beyonce always sings about, the area to the left. So we're going to put 0.4 as the area, the mean of 5.85, and the standard deviation of 0.24. Again, that all came from the word problem. Press enter, and we'll find the lower value of 5.789. We'll just call this 5.8. Well, I guess the mean is given to two place values. We should keep this to two place values. 5.79. Again, the mean was given to two place values. The standard deviation was given to two place values. We'll keep this one to two place values as well. All right, so in my calculator, I can only use the area to the left, so I can find the area to the left of the upper value by adding 0.4 plus 0.2 to give me 0.6. Let me go a little bit thicker here so you can actually see what I'm writing. This would be the area to the left of 0.6. So I'll hit second. I'm going to change it up again. Second entry. Go back and change this to 0.6. Probably would have been faster to use second vars. Again, if you have the older display calculator, you just have to use the comma wherever you need to type the commas in. And we'll get that the upper value is 5.91. All right, last part of this is finding the 90th percentile for the diameters of mandarin oranges and interpret it in a complete sentence. All right, well, the 90th percentile, what does that mean? That means the value that has 90% of the distribution to its left. So there is some value way over here that has 90% of the values to its left, or 0.9. 90% equals 0.9. And we want to find that value. Again, we know that the mean is 5.85. And these are quite straightforward. In the TI calculator, we're just going to press second vars. Number 3, area is 0.9 because it's to the left. Mean and standard deviation stay the same. Press enter. And we'll find that we get 6.167. centimeters. So it says interpret it in a complete sentence. Well, this means that 90% of the mandarin oranges on this farm will have a diameter of 6.16 centimeters or less. All right, thanks for watching. Hope you enjoyed it.